Hello, I'm going to walk you through how to import and navigate around your volume graphics dataset today. So the first thing we need to do is open up volume graphics, and you can see this is VGStudioMax 3.4.0. We can then go to File, Import. If you have a volume graphics file, you can import the VGL volume. If you have a series of images, you can import them as an image stack. So we're going to click on the VGL volume, and we're going to navigate to our data set here. And you can see there's a series of different files, including this PCA metadata file, but this is the VGL file we need to open. There's the volume file with all the information in it. This is the VGL file we need to open. Click Open, and the next step to click Next, and then we click on this histogram button, and this will allow us to set the material and background properties and gray values. So we click on this calibration tab here, open that up full screen so you can see what you're doing. And you see that the bones in this scan are very dark, and the whole thing's quite dark, and probably because there was some very high density material that's pushing everything down to that darker spectrum. So if we click on this dark background here, define background here, and then drag a little circle or a square around the dark area, the air in this particular case. And then we click on this define material, and we click on an area of bone. Let's click it here. And then you'll notice that the map to settings are set to 10,000 and 50,000. So 10,000, these are about 10 and 15,000 gray values off the limits of the 16-bit system. So that gives you a little bit of extra room on either side in case you haven't selected the darkest or the brightest areas. And you click Apply, and you'll see that's a lot nice and clearer now, right? And you can even go back afterwards, and if you think that you haven't selected the kind of the brightest part, you can click on that and click Apply. Okay, so hit Hide. The next thing you can do is click Preview if you want to trim down your volume a little bit. So it'll give you, this is the cross section here, but it'll also give you this maximum projection across an area here. So you can see that we've got, if we're interested in the skull of this thing, there's a little bit of the arm that we can crop out here, maybe. Crop this fellow out here. We can trim it down a little bit, and we're just making the data set a little bit smaller. We can click on the right projection. That's going to show a different view. We can, if we're interested in just the skull, we can trim it down further. And front projection here, and you see I've actually messed up a little bit, so I can move that out a bit. And now we've got the skull in the field view. And click Hide and hit Finish, and that's going to import the volume, and you'll see it visualized in 2D slices on these three windows here, and then in the three-dimensional view on this window here. And these are orthogonal sections. So this is the XY plane, this is the ZY plane, and this is the ZX plane. So if you use this mouse wheel or a trackpad, and you hover over a particular window here, you can scroll up and down through the slices, and you can see on the other slices where that image looks, where the image is, and you can do that here. You can see this is blue for the XY plane, and green for the XZ plane, and red for the CY plane. Okay. You notice on the fourth window here, there's a three-dimensional image that shows the isosurface, or the presence-absence view of this data set here. And then you'll see that the volume is imported into this scene tree. And then under the rendering tab, you'll see this histogram. So this histogram is a frequency histogram showing the gray values of all of the voxels inside this data set. So if you can turn off the linear scaling here, and you see that there's a big spike here that corresponds to the darkest part. So it goes from the darkest or the lowest density over here to the highest density over here. So the big spike here showing the lowest density parts, and that's obviously air. And there's another spike here that's going to be the soft tissue here, this kind of medium gray color. And then the actual bones are probably restricted to this tail off part here. So this red line is the isosurface line, or the ISO 50/50 line, where you can essentially everything to the left of it is transparent and everything to the right of it is opaque. So if you move this isosurface line to the left, you're making the air now opaque, so you can't see anything. It's not as helpful as moving it to the right. So now the air is transparent, but the soft tissue is opaque. And if you move it past this line, what you'll see is you're moving this to the point where your soft tissue becomes transparent, and your all that's remaining is the bones here. And if you move it all the way to the right, you'll see that you start losing even the bones and just getting the kind of the densest parts here, which are the long edges of the long bones. All right. So we'll move that back to here. And that's a quick way of visualizing your specimen in 3D, assuming that you're interested in visualizing all the dense parts and none of the low density parts. One thing we can do in addition to this is, if you notice, as we scroll through here, you'll notice that this scrolling plane is not, this clipping plane is not, rather the tomogram slice is not actually moving in a nice symmetrical way, right? It's not not what would be a coronal section on this. So we can actually reorient these slices to fit that plane, because these are just a series of voxels that can be sliced any which way. So one quick way to do that on this software is to do a simple registration. So you click on this button up here. So it currently says 321, but you click on this button and click on simple registration, and that will allow you to rotate your specimen. And you see, as you rotate in one plane, it actually cuts through the planes in a different way this way. So we can now rotate it this way, and we can rotate it this way, and you can keep on rotating it until you get a nice cross-section that is symmetrical in all these different planes. We can move this by clicking on the square in the middle. If you want to reset it, and we can move this up. So now, when we click finish, we'll move this back. When we scroll through the slices, you'll see that now we're looking a nice square on to the head here, and that makes it much easier to do the segmentation work, because most of the structures that you'll be looking for in this situation are probably symmetrical, and so you can check to see if the structures you're looking at occur on both sides. Okay, so if you wanted to, let's say you wanted to just visualize the skull without any of the other parts, this tag, or maybe this other part of this list that we scanned at the same time, or the postcranial skeleton, we might want to create a region of interest that which is a collection of voxels that just contain the voxels that are associated with the skull. So the way we do that is using these tools on the right here, which are the drawing tool and the region growing tool and the polyline 3D tool, to isolate out a series of these voxels that we can then view in isolation. Okay, so let's click on this region growing tool, and there's a series of different tools here. The region growing tool is one we'll use today, and we can zoom in by holding down Control and scroll wheel, and we can click on this area, and holding down the left click, we drag a circle, and it's going to, what the region growing tool is going to do is it's going to select everything that's within a certain gray value distance of that initial voxel that you clicked in 3 dimensions, in all 3 dimensions in a circle. So you see in this plane we've grown out a circle, in this plane we've grown out a circle, in this plane we've grown out a circle. So it's actually a sphere. If we want to grab less, if we want to be a bit more restrictive in the gray values that we're selecting, we can drop down the tolerance. So that's this number here, and you can see that now we've selected, we've only selected the more similar gray values, the voxels that are connected. And you notice that with this area here is not is within the circle, but is not got any connection to this to these structures here that are within that that tolerance. So if we increase this tolerance to, let's say, 3,000, it's going to select everything, right? If we go to 2,000, maybe it'll start selecting. It'll avoid some of the lower density parts, but it's going to grow out everything. So you can play around with these gray values here until you get to the part that you want. So say at 16,000, that that tolerance can jump across that gap, but at 6,000, it can't. So once we've got a segmentation or a selection in this yellow line that we're happy with, we can click on this button here, which is the create new region of interest, and that's going to add a region of interest to the scene tree that is now essentially like a layer in Photoshop. It will be a group of voxels that you can modify and visualize in isolation. You can now, once you've selected another part, you can click on this add to region of interest, or you can replace that original region of interest, or you can remove it from that region of interest, or you can create a new region of interest. I'm going to add to a region of interest, and I'm going to click Shift Alt A, and that will add that to that region of interest. Now, if you look on the 3D window, you can see that there's a little box around that area that I've worked at, and you can see this is the area that I've been adding to the region of interest. We can't visualize that yet because of two things. One, the rendering settings on this region 1 are turned off, and two, it would be obscured by the fact that we're visualizing this volume by itself already. So the first thing we do is turn on the rendering settings on the region of interest, make sure you have that selected, and then push the V+ button. And now you have the histogram is going to show you the density of the voxels within this region of interest. But we still can't see it because it's being obscured by the volume. So we need to click on that volume and turn off the visualization by turning the transparency on this setting to 100. And now we can view that area that we've grown out all by itself. And so this is an individual series of voxels that correspond to a particular group that we've sectioned out. Now, if you are confident that you've got your tolerance settings in a good way, you don't even need to drag a circle. You can click on an area, and it will just grow out everything within that scene that is attached to that area. So if we click on this bone here, now we add that. See that that's actually just grown out everything that was connected to that initial point within a specific tolerance. Now you can also click on lower, darker areas, right? And if we keep the same tolerance, you'll see that you're just growing out darker parts or lower density areas here. So we're growing out the skull relatively quickly this way, right? Now, a second way of doing the segmentation is using the draw tool. Or this button here. If you click on this, this will do is it will create a kind of a circle, what looks like a circle, it's actually a sphere, that you can then either add to a region of interest or create a new region of interest by clicking on this. And you see we're growing out everything within this region of interest. But let's undo that by Control-Z, or you can also push this back arrow here. And the new features on VGStudioMax allows you to restrict the pen tool to a certain series of gray values. So if we wanted to just segment out the bones in here and leave the background, we can set a lower density, a lower threshold to whatever this bone density is here. So how we work that out is by clicking on this little button here. This is the navigation cursor. This allows you to click around, and when you click, hold down Control and click, it will take you to whatever slice that this little crosshair is on. So let's say we wanted to grow out the palette here, palatine, sorry, the pterygoid rather. We can click on this, and the bottom left-hand corner of the screen, it will give you an information about what the density, what the gray value in numbers, the numerical gray value of that is. So that's 43,000. Let's go to a little dark area because we want to get some of this. So let's go down to about, yeah, maybe about 30,000. You see that on the bottom side of the screen. So we turn this pen tool on, we can set this lower limit to 35,000 and the upper limit to 65,000 because that's the top, that's the upper limit of the 16-bit TIFFs. And then you can now, if we drag, you'll see that it's just selecting the area that we're interested in. Now this might actually be a little bit high, so let's try 30,000. Now we're selecting all of the bone here, you see, so in a sphere. And you can make this pen tool larger by holding down Shift and using the scroll wheel. Oops. And we can quickly and easily go through and isolate out the region of interest that that we are wanting to visualize. And so this is a quick and easy way of isolating out the various different parts. It's worth mentioning that when you're doing all this reconstruction, there will always be an easier or a better and a worse view to be looking at when you're doing the segmentation. And I usually try to focus on the transverse sections like this. Whereas if you're trying to segment out things that are laying one on top of each other, and very proximal to one another, it can be quite difficult to do this from an oblique angle. So this is why it's another reason why it's good to reorient your slices so they're nice and symmetrical. So you see, as you go in real time, your 3D window is going to capture your new additions to the region of interest here. So as you move around, scroll through and up and down, you can see this. All right, so let's just assume that this is, what we can do is make the pen tool really, really big, and that'll make it go much faster, although we lose a little bit of accuracy with this. Let's click on this a couple of times just to get most of the specimen added. Here. And let's say during my cooking, I've accidentally grown out some of the fingers here, right? I want to remove them. Well, there's another tool for this. This is the 3D polyline, or the polyline 3D tool. If you click on that, this will allow you to, in the 3D window, if you hold down Control, you can click and add a polygon over your area that you want to remove, or add, but remove in this case, and we can just click on the surface, the subtract from region, and that will remove that area. Now you may notice that there's some odd-looking parts in here, and if we scroll to where we've looked at that, we probably have actually segmented that out. What you're seeing here is this isosurface line, again, is not all the way to the left, so we're only seeing the denser parts of the structure. So if we move this isosurface line to the left here, now you can see that all of the skull that we've segmented out is present. Okay, and if we zoom all the way in, you'll see that there's actually some, looks like lines on a topology map, right? So these are actually the voxels that are showing up. These are the square voxels or cubic voxels that are making this pattern. Volume Graphics has a feature called edge refinement, where if you click on it, it will actually interpolate between the voxels, working out where it thinks the actual edge of your structures is based on the edge of your region of interest. And if you click replace here, it will actually create a nice smooth surface. It should create a nice smooth surface. And there you have it. So it's a nice smooth surface, and there's your skull segmented out. Now let's say you wanted to remove all of these isolated pieces from the structure, and you're pretty confident that all of you just want to have this single structure that's all linked together, we can actually use this split ROI feature to just reduce the images, or segment out individual regions of interest that contain certain numbers of voxels or more, right? So let's say we want to get rid of all these little pieces. We can say, let's just keep all of the parts that are larger than, let's say, 10,000 voxels. And you can see once you've applied that minimal threshold of 10,000 voxels, which isn't very much, by the way, 9 components remain. Let's go up an order of magnitude. Okay, so now we have 100,000 voxels. So we want to retain all of the parts that are connected that contain 100,000 voxels or more. We click OK. That will now create 2 new regions of interest. We can turn this off. 2 new regions of interest that contain 10,000 voxels or more. So you can see one of these is the quadrate here. You see it just happened to be not connected to the skull. So we've got the quadrate segmented out. And then the other one is you see everything but the quadrate. But we've lost all of these little floaty bits here. So that's another quick and easy way of removing voxels or stray parts of your segmentation now. You can see in this corner here, this is really a thing because we haven't segmented out. So I used the navigation cursor, held down Control and clicked, and that took us directly there. And you can see that, yes, I haven't added my region of interest, hasn't grabbed all of that internal stuff. So I'll just use the region growing tool here, Control, Alt, A, Control, sorry, what is it? Alt, Shift, Control, Shift, Alt, and A, and that will add that to the region of interest. You can still see we've got these voxel lines here, so we'll have to do another edge refinement. And we've obviously missed the part of the back, so we can go in and segment that out. There's our back of the brain case here, and I might look at a different angle here. I can scroll through to see. Now I've grown up too much here, so I either want to select a slightly brighter part here, or I reduce the tolerance down to, let's say, 2,000, where it's not going to jump across that gap. So I'm going to keep on playing around with this until I get the right limit of that part of the skull. So once you've done this, this is the sort of thing where maybe the pen tool would also be very useful. But we can keep the tolerance low and keep the circles that I'm drawing small, and it will grow out that in time. All right, and so we have a pretty good skull here.